All right, guys. So now we'll move on to the next part of our lesson. So we are going to discuss about conditional probabilities in Venn diagrams. Okay, so still the rule doesn't change. Conditional probability, you now have an introduction to it in the previous part. We discussed how to find conditional probabilities, but that was in two-way tables. Now we are going to learn how to find conditional probabilities in Venn diagrams. So the theory is exactly the same. The theory is exactly the same. So you just have to apply the same knowledge into this as well. Okay, so let's see how it's done. So in exercise 4, question number 1, they say the Venn diagram shows the probabilities for two events A and B. So you have the two events A and B. Okay, find the probability of A union B. So guys, you guys know how to get this done, right? So these are parts we covered previously, A union B. So if you recall, we did this even by using region numbers, right? So we did do A, B, C. You don't need these kinds of stuff actually. I think A union B is pretty simple, right? A union B is you have everyone in A and you have everyone in B, right? So union means you take everyone. Intersection means you take only the common regions. Do you recall? So I believe you understand that A union B will have the regions is simple A, simple B, and simple C. The reason I'm using these letters is so that you know which region I'm talking about. By the way, you don't need to mark any of these regions in your exams. Okay. The reason I'm marking this is so that you know which region I'm talking about. Okay. Okay, so basically A union B will include all the regions in A, that is AB, and it will include all the regions in circle B, that is the simple BC. So it includes A union B will include all three of them, A, B, and C. Agreed? Okay, so these are topics we covered previously. All right, so basically you have to add the three probabilities, 0.3 in region A, 0.12 in region B, and 0.28. So add them all together, and how much is the answer? So we have 0.3 plus 0.12 plus 0.28, which gives me 0.7, right? That's 0.7. That I think that's pretty clear, right? All right, we'll move on to part B, probability of A given B. Okay, now guys, look at this. Probability of A given B. Okay, how do we get conditional probabilities? From Venn diagrams. This is the main part. This is what we are trying to discuss here. So when they say A given B, it means B is given. So which means this is the event B. Can you see the event B is given? Okay, so in event B, the regions I have marked are simple B and simple C, right? So simple B and simple C are the given events. Can you see? In simple, I mean, I've just labeled regions here to make things easy for you guys. So inside the set B, inside the set B, that's the given one. Okay, the one after the vertical line is a given one. So that includes the region BC. Now, from those regions, okay, so you can write the total of that actually to write your probability. What's the total? So you have to add them in B plus C. So that's 0.12 plus 0.28. That should be your denominator. So we are going to do the exact same thing that we did earlier, right? So your denominator will be regions B and C, 0.12 plus 0.28. All right. So the numerator, okay, how do we get that? So probability of A given B. So probability of A means, now you can see the circle A, circle capital A, the set A. So in that, the regions, now you know circle A, when you come to circle A, the regions belonging to circle A are, can you see the regions belonging to circle A are the simple A and simple B, right? Are you guys with me? So to circle A, we are going with regions simple A and simple B, agreed? So out of those two regions, A and B, you can see B is the region that is already in the given set, because we need to take the probabilities only from the given set, only from the given set. So given set is the circle B, the one in green. So out of that, the probability of A, when you take A includes two regions, simple A, simple B, but you can see simple B is the region that belongs to the given set. So therefore, on top, you should write the probability of A given the given set, that's 0.12, because B is the one in the given set. Are you with me? It's exactly the same as the previous case, but just need to think a little bit more here. So 0.12 divided by 0.12 plus 0.28. So you can type this in the cal and you get the answer 3/10. 3/10 or 0.3. All right, guys. All right, we'll move on to part C. Okay, this A, B, C, D thing is really optional. You don't need to do that. As long as you can identify regions properly, you don't need to mark any of this, okay? Okay, part C, probability B given A dash. Probability B given A dash. All right, so guys, A dash. So the given, always first focus on the given set. So what's the given set? A dash. A dash means not A. So guys, what's not A? Not A means the region that doesn't belong to A, right? So these are the regions that go with A. Inside A, you have region simple A, simple B. So A dash means don't take them. You take the complement. A complement. This is A complement. So outside of A, you have region C and D, right? So that's your given that. So that's the given that. So C and D is the given part. So which means in the denominator of the fraction, you get the C and D probability. So C probability is 0.28. The D probability is 0.3. The outside part, D probability is 0.3. Can you see? So that's the given set. Now remember on the numerator, obviously, then I think you need to now understand what's going to be. Your numerator has to be either something to do with region C, or it has to come with region D. One of these two, C or D, should come on top, because you can't get anyone outside of C and D in the numerator. When it's a given, when it's a conditional probability, it has to be either C should be on top, or either this D probability. One of those two probabilities must come to the numerator. So which one comes? Okay, so on top they say you're supposed to find the probability of B. So probability of B, you can see when it comes to the B circle, you can see when it comes to the B circle, the regions are simple B and simple C, right? So here the regions are simple B and simple C. So guys, I told you now, if you wrote C and D are down here, then on top it has to come be either C or either D. It can't come, you can't get any other region because it's conditional. So you can see the one that works here for the probability of B given A dash. So you can see the region C that works here, right? Okay, so region C belongs to B and it also belongs to A. I mean, it's also in A dash, satisfying the condition. Therefore, it's region C that comes on top. So region C probability is 0.28. Guys, are you clear with that? This is really important. Okay. So the answer 0.28 over 0.28 plus 0.3. So that's 14 over 29, right? Or 0.48275, it goes on. So 14 over 29. All right, guys. Okay, I hope this is clear. Okay, always the given that part probability is written, and on top you have to write the regions, any one or more of the regions from the given that part. You can never have any region outside of the given that part. Okay, so part B, the probability of B given A union B. All right, guys. So now A union B is the given that part. Okay, so what are the regions belonging to A union B? So you guys know when it comes to A union B, okay, you have everyone in A, you have everyone in B, right? All the regions in A, all the regions in B, everyone comes because it's a union. So which means it includes the regions A, B, C, right? You guys can see A union B includes the region simple A, simple B, simple C. All these three guys counts for A union B. So this is the full thing A union B. So which means over here the denominator is going to be 0.3, that's region A, 0.12, that's region B, 0.28, that's region C, because you have all three of them in the given that, A union B. So A union B comes to the given that. Now what should come on top? The numerator has to be either A, either B, either C, or any combination. You can even have A plus B, but it can't go out of this. So you can't have anything to do with region D here. Okay, you can have any amount of regions corresponding to either A or B or C, or any combinations of A plus B, B plus C, anything is fine. So now how do we get that? So we look at what we are supposed to, the probability of B. Okay, so probability of B, what are the regions we have in circle B? So circle B is the green one I have marked. You have the regions B and C. So guys, when we take the regions B and C, I'll write it down separately. So for B, we have the regions B and C. So you can see B and C are both in this, both in A union B. So therefore we are writing things that belongs to the given that set. So therefore both B and C can come on top, right? Because the circle B has regions B, C, and both B and C are in the given set, isn't it? So therefore both B and C probabilities can come to the numerator. So B probability is 0.12. C probability is 0.28. All right, guys. So this is how you get the answer. So what's the final answer? Let's get it. So the answer is 4/7. You can give it as a 3 decimal, but make sure you give the significance. Okay, so yeah. Okay, so I hope this is clear. All right, guys, we'll move on to question number 2. C and D are two events such that probability of C equals 0.8, probability of D equals 0.4, and probability of C intersection D is 0.25. Draw a Venn diagram showing the probabilities for events C and D. So let's draw the Venn diagram. Let's first draw the two circles. So you have the two events C and D. Okay, so then they say the probability of C is 0.8. You know, when they say probability of C is 0.8, C includes this entire circle. So you should mark the 0.8 probability at the top, right? Okay, because it means that the total of the circle is 0.8 and probability of D is 0.4. So this entire circle D adds up to 0.4. Okay, both the regions. Okay, so regions are optional. This is what I marked. The regions are optional. You don't need to mark them. Okay, that's just making it easy for me to point out regions to you guys. And then probability C intersection D. So C intersection D. Now intersection means the region that's common. So the region that's common to both circle C and circle D is what? Intersection of the two circles are this region D. Can you see this region simple B? So that should be 0.25. That is 0.25. And then I think we can now find the answers for regions A, C, and D, right? So region A should be the total value of the circle is 0.8. So from 0.8, you can subtract the 0.25. So how much is it? 0.8 minus 0.25. Yeah. So that is going to be A is going to be 0.55. Yeah. And then region C is going to be the full circle is 0.4, right? So from 0.4, you subtract the 0.25, right? So that is how much? B is 0.15. Yeah. And then how do you get D? The way you get D is you don't take 0.8 and 0.4. That's wrong because you need to consider individual regions. So A, B, C, D, all 4 regions add up to give you 1. So all you got to do is add the regions A, B, C and subtract it from 1. Okay, so 0.55, you add with 0.25, you add with 0.15 and you subtract it from 1. And then the region D answer, you get 0.05. All right, guys, add these three, add the 3 individual regions, subtract from 1. Okay, so now I have all the regions. Now we can find the answers. Okay, so B part 1, find the probability C union D. Okay, so that's simple, right? I mean, that's a quite a thing that you have done in the previous part. So C union D, set C, union set D means you take all the regions belonging to circle C and circle D. So that means it includes regions A, B, C, all 3 of them, right? Okay, so everyone includes there. So just add them all 0.55, 0.25, 0.15. How much was it? How much is it? Zero 0.55, 0.25, 0.15. When you add all of them together, the answer is 0.95, right? Okay. All right, Roman number 2, you're supposed to find the probability of C given D. So given, so when you see the conditional probability, you know the rule. First, go for the given that. So the given that part is D. So when it comes to set D, what are the regions belonging to set D? You can see we work with region simple B and simple C. Right? Can you see? Simple B and C, which means simple B and C are what comes, are the regions that comes to our denominator. So simple B has a probability 0.25, simple C has probability 0.15. So you know how conditional probability works. If B and C are there in your denominator, it has to be either B or either C or either both of them in the numerator. Okay, so then what's the probability of, what are the regions belonging to C? Now let's get the probability of C. So C includes the regions. You can see circle C includes the region A and B. So which one do we require? You can see it's B. Okay, you need to go with B, right? Because B is what belongs to the given that set. This is the given set. Okay, so D is the given set. So from the given set, the probability of C includes region B, which belongs to both of them. So region B is what comes on top. That's 0.25. So what's the answer? The answer 0.625. Yeah, 0.625. All right. Okay, so let's move to the next one. Roman number 3. Probability of D given C. So always your focus should be on the given that. So given that is now C. So go on with C. This is the given probability. So what are the regions belonging to circle C? In circle C, you have regions A and B. Can you see? In circle C, you have regions A and B, which means A and B are your denominator. So A has the probability 0.55. B has the probability 0.25. So that's A and B. And now from that given set, you have to get the probability of the D from the given set. Okay, so what do we get now? So remember the C is the given one. So remember it has to be one of these two A or B regions that has to come on top. You cannot write anyone else. So D, what are the regions belonging to circle D? The probability of D given C. So D, inside circle D, we have the regions B and C. So which one works with the given set? Out of these two regions, which one works with the given set? You can see it's B, who is corresponding with the given set. See, B is corresponding to. So therefore, probability of B is what should come on top. So B probability is 0.25. All right, guys. So what's the answer for Roman number 3? You can simplify in the cal and you can get the answer as 0.3125. 0.3125. All right. So last part. Probability of D dash given C dash. Okay, so now the given probability is C dash. So guys, you all know how to do this. C dash means what? The complement of C. So this is C complement. So that means you take the regions outside of circle C. So what are the regions outside of circle C? So inside circle C, we have regions A, B. Outside of circle C, we have the regions C and D. Are you guys with me? So this is the given that. So this is the given that. So you write C and D in the denominator. C probability is 0.15. D probability is 0.05. Agree, guys? All right. So now the numerator has to be one of the C and D. Okay. So remember, this is the given that. Okay. So this is my given that. Now we need to get the probability of D dash. So what comes for D dash? So what comes for D dash? D dash means the regions, or D complement actually is corresponds to the region who are outside of circle D. So outside of circle D, okay, inside circle D, I have region BC. Outside of circle D, I have the regions A and D. I have the regions A and D. Can you guys see? D dash. Outside of the circle D, I have the regions A and D. Inside BC, outside AD. So which one corresponds with the given that? So which one of these two regions correspond with the given that region? It's D. D corresponds with the given that region. So therefore, D should come on the numerator. D is 0.05. The region D has a probability of 0.05. All right, and you can get your answer. That is 0.25, right? All right, yeah. So we have the answer 0.25. All right, guys. So I hope this is clear with you guys. All right, guys. We'll move on to question number 3. So finally, we are coming into the part where we are going to deal with independent events. I think at the beginning of this part, I was explaining to you about independent events, right? So over here, if you recall a previous theory that we learned, okay, a previous theory we learned a few sections ago. So if you need to recall that if two events are independent, okay, so if two events are independent, the probability of A given B, the probability of A intersection B is equal to probability of A times probability of B. All right, so this was a rule that you have learned. All right, guys. So this is just me showing you. This was in section 4.3. So we discussed about mutually exclusive and independent events. So that was a long time back, right? So probability of A and B. If two events A and B are independent, A and B, in other words, at that point I have explained that it is intersection, right? Is equal to PA times PB, right? So this was discussed some time back. Okay. Okay. All right, so let's go with the question now. So in question 3, they say S and T are two events such that probability of S equals 0.5 and probability of T equals 0.7. Given that S and T are independent, draw a Venn diagram showing the probabilities for events S and T. Okay, so first thing is we'll draw the Venn diagram, but also let's use the fact that the events T and S are independent. So since T and S are independent, what do we know? T and S are independent events. Therefore, when events are independent, what's the rule we are allowed to use? Probability of T intersection S, or you could even say S intersection T. That's perfectly fine. Is equal to probability of T times probability of S. So this is the rule that you're allowed to use. Okay, so probability of T is given to us as 0.7, probability of S is 0.5. Guys, once again, if you change the two letters, that's perfectly fine. If you write S intersection T, that's also okay. T intersection S, both are the same. Okay, so 0.7 into 0.5, that's 0.35. Can you guys see? So we know the intersection probability. Okay, so now we can go for the Venn diagram. So you know the intersection probability now. All right, so I named the region TS in probability of T 0.7, probability of S is 0.5. So T intersection S is the middle, right? The intersection, T intersection S is 0.35. I'll mark my regions A, B, C, D. You don't have to do it. So, okay. So that's just for me to identify, okay, and for me to speak with you guys. Okay, so 0.35 is the intersection. Can you guys see? All right, so everything is marked. Now you can see I can easily find the regions A, C, and D. Okay, so how do I get the region A? Yeah, so you subtract, right? So see from 0.7, you subtract 0.35. 0.7 minus 0.35, the answer is 0.15. Okay, so that you have to get it through the subtraction. All right, the next part, so the region C, so you can see B plus C is 0.5. So from 0.5, you subtract 0.35, and that gives you from 0.5, when you subtract 0.35, what do we get? Then mark it. Wait, give me a moment. Yeah, I think this is wrong, right? Yeah, sorry, this is wrong. So according to the way I have marked 0.3 from 0.7 when you subtract 0.35, I'm sorry. From 0.7 when I subtract 0.35, it's 0.35. Right? From 0.7 when I subtract 0.35, it's 0.35. And from 0.5 when I subtract 0.15, this is 0.15. Okay, guys? Sorry about that. Yeah. Okay, so this is 0.15. This is 0.35. And then the outside region, you should subtract everyone. Okay, you should add all these three regions individually and subtract. So 0.35, 0.35, 0.15, and you subtract. So then the outside region, when you subtract the individual regions from 1, you get 0.15. All right. Okay, so that's done. Now let's move on to the questions. Roman number 1. Probability of S intersection T is done, right? S intersection D, actually we have found part B part 1. Okay, so we have found that, or we can just write it again. S intersection T is 0.35. That's all we done. Roman number 2, probability of S given T. All right, so it's given that situation, conditional probability. So take the given that part. Okay, so you know, given that part is T. So under T, what are the regions coming? So under T, I have the regions A and B. That's my given that. So A and B probability should come to the numerator, should come to the denominator. AB probabilities come to the denominator. So A probability is 0.35 plus B probability, right? Plus B probability is 0.35 A and B. And then, so this is the given that one. Okay, so from the given that part, what are the regions that can come to the numerator? So S, given you're supposed to find the probability of S. So what are the regions coming for S? Inside region S, we have, inside the circle S, we have regions B and C. B and C. So the one that corresponds to the given that, you can see it's B who corresponds with the given that, right? So B corresponds. So B probability 0.35 comes on top. And what's our answer? So Roman number 2, yeah, it's 0.5, right? Okay. Then Roman number 3, probability of T given S complement. Probability of T given S complement. So let's take the first, the given that is S complement. So S complement means the regions that don't belong to S. So S complement, the regions that don't belong to S are A and D. Can you guys see? Inside the circle S, we have B, C. Outside of circle S, we have A and D. That's the given that part. So that should come to the numerator, denominator. So A is 0.35. D is 0.15. And then S dash. So S dash means that's done. S dash is done. So the probability of T. Now, from the given that part, so what are the regions coming inside circle T? Inside circle T, we have regions A and B. So which of these regions are corresponding with the given that probabilities? With the given that region, it's A. A corresponds. So therefore, A probability should be written at the numerator, 0.35. All right. So the answer for Roman number 3 is, yeah, 0.7. All right. So the last part, Roman number 4. Probability of S given S dash union T dash. Okay, so give an attempt on this first. All right, guys, moving on to part 4. So probability of S given S dash union T dash. I think first we'll have to go for the given that. So what is S dash union T dash? Let's first find that, right? Okay, so S dash includes all the regions outside of circle S. So outside of circle S, we have region A and D. Agreed? S dash includes regions A and D outside of circle S. S complement includes the regions outside. Next, T dash or T complement. T complement takes the regions outside of T. So outside of T, we have the regions C and D. All right. So then this is a union. So you know what union means? You take everyone. Okay, not the common. This is not intersection. This is union, which means you must take all the regions that are in both the sets. All right. So it's not intersection. If it's an intersection, you take only the common region. But here, pay attention to the type of operator. It's union. So which means you get A, you get C, and you get D. Even though D is common, D comes once, and the others also come as well because it's a union. So that's what we have. So this is our given that. So now A, C, and D are the given that region. Are you guys with me? So that's what comes to our denominator. So A probability is 0.35 plus C probability is 0.15 plus D probability is also 0.15. Okay, now let's write the probability of S. Okay, so what are the regions coming on S? So the probability of S given S dash union T dash. So now write the regions corresponding to S. So in S, we have the regions B and C, right? B and C. And out of those two regions, who are the ones corresponding with the given that region? So given that regions are A, C, D, S has the regions B and C. So you can see from the two regions, it's only C who corresponds with this, right? A, C, D. It's only C. B doesn't work. So C probability, the C region probability should be written in the numerator 0.15. All right. So the answer is gonna be simplify, you need the calculus is 3 over 13, right? 3 over 13, or in other words, 0.231, correct the three significant figures. Is that clear, guys? All right, over here, I want to emphasize one important thing. Okay, so one rule. Now, you did, I did teach you at the beginning of this session something about the conditional probability, right? So we were discussing the previous part, I believe. Yeah, so this, I think this was in the previous part. At the beginning, I was talking to you guys about independent events and conditional probabilities with independent events, right? So if that events are independent, then probability A given B, if A and B are independent, then A does not depend on B. You can see we never used this so far, right? So we were doing the sums entirely using manual calculations, okay? Because we didn't come across independent sums so far, but now we came across an independent sum. So now let's just see how we could use these theories also to get the answer. So if events A and B are independent, I explained to you in the previous section, okay, in the previous video. So that was, we learned that probability A given B is equal to probability of A. Why? Because A doesn't depend on B. If events are independent, they don't depend on each other. Probability of A given B dash also is directly probability of A. It doesn't depend on B. All right. So taking that into consideration here, now over here, T and S are independent events, right? So if T and S are independent, guys, what do you have to say about this Roman number 2? Probability of S given T, if S and T are independent, if S and T are independent, what's gonna happen? Probability of S given T. So the probability of S happening given that T has already happened. So regardless whether T happens or whether T does not happen, that makes no event on the happening of S. So probability of S given T is equal to probability of S, right? Because T is the one that has happened and we need the probability of S happening. So the probability of S happening does not depend on T because they are independent. So guys, is that the case here? Probability of S given T. Did we get the answer of probability as 0.5? Is that the probability of S? Yes, I think you can see here. Here, probability of S is 0.5. Can you guys see? So I actually, even though we did this manually, we got the answer, right? So this is the probability of S. Can you guys see? So instead of going through this, you could have written at once. You could have written your answer at once. This one, the probability of T given S dash. Since the events are independent, okay, T and S are independent, the probability of T happening, does not depend on whether S happens or whether it doesn't happen. So over here, the probability of T happening given that S has not happened. The event S has not happened. So in that case, since the events are independent, T doesn't depend on S. Whether it happens or it doesn't happen, T has no effect. So this is equal to probability of T. So guys, is that the answer we got here? 0.7. Is that the probability of T? Yeah, right. I think you can see here probability of P is 0.7. So we got the answer, even though we did this in the manual way. You can see that we can get these two answers without going through these calculations. Okay, so in the exam, these are some important shortcuts because sometimes they might not give you all the probabilities you require. And then you might be asked to find such probabilities. And then you need to directly apply the theory in order to do the sum. Otherwise, you might get stuck. Now, over here, since all the region probabilities are provided, we could go in both the ways, the manual way and also now just the shortcut. But in the exam, it's really important that you know the shortcut and that you don't depend on this, but directly you go to the final answer. That's important that you know it. Okay. All right. So I hope that this part is clear with everyone now. All right, guys. We'll move on to question number 8. So three events A, B, and C are such that A and B are mutually exclusive, and B and C are independent. Okay, guys. So there's so much information here. Number one, A and B are mutually exclusive. So you know if two events are mutually exclusive, they have no intersection. Basically, if you're drawing, the circles must be drawn separately. The intersection of A and B is 0, the probability of A intersection B is 0. 0 means it's not happening. That's an event that's never happening. Okay. And B and C are independent. So guys, you should know if B and C are independent, if B and C are independent, then you should know probability of B intersection C must be equal to probability of B times probability of C. So this is the rule, right? So we can find that because probability of A, B, and C are given to you. Probability of A is 0.2, probability of B is 0.6, probability of C is 0.5. So 0.6 into 0.5, that's 0.3. All right, that's 0.3. Okay, and they have also given you another extra probability. Okay, before we go into that, we need to draw the Venn diagram and mark all the information. Okay, so basically, first thing I understand is there are three events, A, B, C. But am I going to draw the circles in such a way that all three intersect? Do I have to draw something that looks like this? No, right? Because they say A and B are mutually exclusive. So if A and B are mutually exclusive, you do not need to make the show that the circles A and B join. So they don't join. So in that case, what you need to do is circles A and B are not going to have any intersection with each other. All right, so let's take 3 circles. So these are the 3 circles. Now, how do we arrange them? Circle A and D shouldn't meet with each other. Okay, so let's say this is A, B, C. So let me keep the C here for now. So right now, circle A, okay, and circle B, they don't meet with each other. So there you don't draw it like this intersection. You draw it like this, right? You keep A and B separated from each other. Okay. Okay, so this is A and B. And then now what about the circle C? Now they say B and C are independent. Of course, if they're independent, there is an intersection. But that doesn't mean that the dependent events don't intersect, right? They still intersect. So they don't tell you anything about, now this is circle A, this is circle B. Okay, so this is A and if this is B, we know A and B don't meet, but they don't tell you anything that about A and C. Right, so we can't assume that A and C also doesn't meet. So you'll have to mark position C in such a way it meets both A and B. Are you guys with me? So something like this. Can you see? So circle C intersects with A and it intersects with B because you can't assume it doesn't intersect because they don't tell you so. So you'll have to do it in a way that they intersect. So this is the Venn diagram. All right, guys. So this is the Venn diagram. So now we'll mark our regions. So I'll give these names A, B, C, E, E, F. So this is just my own choice. You don't have to mark these stuff. Let's mark the important things. So the important things here, there are things that we found. What are they? Probability of A is given. Probability of A is 0.2. So mark that. So A is 0.2, which means the entire circle A is 0.2. Probability of B is 0.6. That means the entire circle B is 0.6 here. Can you see? Probability of C is 0.5. The entire C circle is 0.5. Okay, and also we found the intersection probability. Probability B intersection C. Then can you guys see the intersection of B and C? Probability of B intersection C is 0.3. So B intersection C, the intersection is region D. Can you guys see? So this probability is 0.3 because this is the place where the circle B and circle C intersects. Right? This region is where they intersect. So you can mark all these probabilities. Okay, so with this, let's find what we can find. I can find the value of region E. Right, if this region D is 0.3, 0.6 minus 0.3 gives me this answer also as 0.3. Okay, okay, and then what about the others? I think you can see I can't immediately find the other regions, but they have given us another extra piece of information. What is that? Let's look into this. They have told you probability of A dash intersection B dash intersection C dash is 0.1. Are you able to get this region? Who is A dash intersection B dash intersection C dash? You have to get the region. Shall we get it? So it's an intersection of three regions. So the common region that belongs to A dash, B dash, and C dash. So let's find it. Okay, so I'll go for this A complement. Who is A dash or A complement? A complement means all the regions outside of it. So inside of A, I have region A and B, simple AB. Outside of A, I have the region C, D, E, F. Agreed? So this is C, D, E, F. Okay, let's go to B dash. What is B dash? Inside the circle B, I have the region D and E. You guys are with me? Inside the circle B, I have region D, E. So outside, I have the regions A, B, C, and F. A, B, C, and F. All right. And then C dash. So C means the regions inside circle C. Inside circle C, there are three regions. Inside the circle C, there's B, C, and D. Outside of circle C, outside I have A, E, and F. A, E, and F. Right? I hope this is clear with everyone. So now I'm supposed to take the intersection of all of them. So that means I need to take the region that belongs to all three groups. A region that belongs to all three of them. So which one belongs to all three of them? I can see so far, yeah, F belongs to all three. Can you see? F belongs to all three. Is there anyone else who belongs to all the three? F belongs to all three. What about, is there any other region? A belongs to the first, no, B, E, C, no, it doesn't. There's no other region who belongs to all the three. Can you guys see? So the only answer is F. That's it. So which means this 0.1 corresponds to region F. So region F answer is 0.1. Is that clear? So that answer is 0.1. All right. All right. So over here, now I need to get the probabilities of A, B, C, because when they ask you to draw a Venn diagram to show the probabilities, you need to make it complete. Okay. So you need to find a way to get the other region. Now, how do I get the probabilities of the other region? Now, look, we need to be a little bit creative here, and we have done sums of this particular type previously. So what you do here is, you know that all these regions, the total probability must add up to 1. A, B, C, D, E, F, everything adds up to 1. Okay, so A probability is not known. So I'm going to pull a little trick here. Guys, you can see here, I'm going to now, instead of now, B and C are both unknown. A is also unknown. So instead of trying to work individual B and C values, I can take automatically the probability of all three of them. Look at this, B plus C plus D. Why am I doing this? So you can see B plus C plus D is the total probability of circle C. Can you see B, C, D adds up to the probability in circle C? So instead of going for individual B, C values, I can say B plus C plus D all together. This adds up to 0.5. Plus region E is 0.3 plus region F is 0.1, and I can get the answer. I can get the individual probability of region A. Can you guys see how to pull this off? Okay, so that's really important. This is A plus 5, 6, 7, 8.9 here, right? equals 1. So A equals 0.1. Great. So A is equal to 0.1. So now you can mark the A probability as 0.1. Now we can easily get the other probability. If A is 0.1, then B probability is 0.2 minus 0.1, which is 0.1. And then BCD, B plus C plus D is 0.5. So you can see here 0.1 plus 0.3 is 0.4. So from 0.4, if you subtract 0.5 if you subtract 0.4 from the 0.5, we get another 0.1, and you can see my Venn diagram is now complete. Okay, so it's really important that you are able to complete your Venn diagram with all the probabilities. All right, guys, so moving to part B now. Find the probability of A given C. So this can be done easily now. So probability of A given C. So C is the given part. So inside the circle C, we have the regions B, C, D. So from this given that, so B, C, D probabilities are what comes to our numerator. So B is 0.1, C is 0.1, D is 0.3. So then you have to get the probability of A. A inside circle A, we have the regions A and B. So out of these two regions, which one corresponds to the ones in the given that? So A is not there, B is there. So B is the one that corresponds, which means B probability should be written at the top. So what's going to be the answer? So what's going to be the answer? It's going to be 0.2, right? 0.1 over 0.5. 0.1 over 0.5, that's 0.2. You can get the answer from the test. All right, the next one, probability B given C dash. Probability B given C dash. So all right, so over here, let's get the C dash. C dash means the regions that don't belong to C. What are the regions that don't belong to C? So inside C, we have the regions B, C, D, right? Inside C. So outside of C, I have the regions A, E, and F. That's my given that. A, E, and F. So that probability should come to the denominator. A is 0.1, E is 0.3, F is 0.1, right? So that is a C dash. So given that, now get the probability of B. So B is going to be the circle B, that's D and E, right? That's D and E. And out of these, so which one belongs to the given that part? B is not there, E is there. So which means E probability should come to the top. E probability is 0.3. So 0.3 over 0.5, right? 0.3 over 0.5 is 0.6. So great. Okay, then the last part, probability of C given A union B. Common number 3, probability of C given A union B. Let's do that. Okay, so A union B. So guys, let's get the A union B probability first. So guys, what are the regions coming to A now over here? Inside circle A, you have the region A and B. Simple A and simple B. Inside circle B, you have the regions D and E. Can you guys see? Inside A, you have the region AB. Inside circle B, you have the region DE. Now take the union of it. Union means you take everyone. Union means you take everyone, not the common thing, which means A is coming, which means you get A, B, D, E. All four of them come. All four of them are coming because it's a union. So write the probability of all four of them. So A is 0.1, B is 0.1, D is 0.3, E is 0.3. All right, so now let's get the probability of C. So inside circle C, what are the regions we have? We have B, C, D, right? Inside circle C. So I have B, C, D. Now out of these three regions, how many of them correspond to the given that? How many of them correspond to the given that? B corresponds, right? B corresponds with the given that, and C doesn't. D corresponds with the given that. B and D correspond, which means B and D probabilities must come on the top. So B probability 0.1, D probability 0.3. Can you see? B is 0.1, D is 0.3. All right, guys, can you see how it's done? So this is going to be 0.4 over 7.8, which means it's going to be half. All right, guys, this is clear. Okay, so this is how you do this sum, right? So I hope that it's clear with everyone.